Ladies and gentlemen, Anita, Schjøll, Brede. Welcome. Thank you very much for coming. Anita, I have just a couple quick yes or no questions. Okay,
Yes.
Ready?
Yes.
Did you ever have, as you refer to it, a real job?
No.
Did you ever develop an e-learning tool in Silicon Valley?
Yes.
Did you ever perform theater for babies?
Yes.
Did you ever get 30, mainly middle-aged men, engineers, to dance to ABBA in front of their co-workers?
Yes.
Did you work on facilitating Solarite business creation in Kenya?
Yes.
Did you drop 6 universities?
Yes.
Did you build a race car?
Yes.
Ladies and gentlemen, this is Disruption in person. Enjoy the speech of Anita.
Wired magazine, 2014. The 3 breakthroughs that have finally unleashed artificial intelligence on the world. Bloomberg, why 2015 was a breakthrough year in artificial intelligence. TechCrunch, from AI to robotics, 2016 will be the year when the machines start taking over. The Guardian, 2016, the year AI came of age. Forbes, why 2017 is the year of artificial intelligence. The Verge, 2018 has been the year of reckoning for AI. The Australian, 2018 is the year of AI. 2019, the year AI will move into the mainstream, according to Forbes. So for the last 6 years in a row, we have been living the year of AI. So why is this? Well, the answer is pretty simple, and it's in line with everything else you've heard from the other speakers. About 2012, we had enough computational power and enough access to data to actually put what has been developed in research for the past 50 to 60 years into practice and solve real problems. So access to data and access to computational power. Now, I think it's really important to notice, and we can turn down the music now, please. I think it's really important to notice that when we talk about AI, especially in this world of kind of hyped media and clickbait articles, that there's 3 levels of AI that we're talking about. The first one is artificial superintelligence, right? The idea that one AI will be as powerful as all human beings on Earth combined. We're not there yet. We will not be for a considerable amount of time. We're also talking about artificial general intelligence, so this idea that one machine can be as smart as one human being. We are not there yet, and it is still a considerable amount of time until we get there. I'll talk a little bit about what remains and what we don't know yet. And so when we talk about AI in 2019 and the 6 consecutive years of AI, what we're talking about is artificial narrow intelligence, or this idea of a machine that can do one thing and one thing only, but it does that far better than what a human being can do. And when it comes to AI, and some of you will have heard this analogy before, but AI, I mean, really, it's just machines, right? It's just software and hardware. It's not that magical. But the main difference between AI-type software, so AI machine learning, and a regular computer with regular software is as follows. Regular machines, regular software works more like a calculator. You give it A plus B, you get C every time. 2 plus 2 always equals 4. While with a machine learning software, what it learns more like a human brain, so depending on the data it has seen over time, it will learn to give more and more accurate results. Now, this is a real easy way to look at the difference between regular computers and computers that can learn, or AI. However, it's important to know that it's an incredibly flawed model for a few reasons. First of all, we don't actually know how the human brain works, so saying that we shape these machines after the human brain is a slight exaggeration. Secondly, we don't really want to build machines that work exactly like the human brain, because our human brains are incredibly flawed, right? We only retain something like 20 or 30% of our memory, and the rest we kind of just recreate as we think about it. We don't want to build machines that work exactly like humans. And thirdly, We don't want to build machines that work exactly like humans because we want to make machines that augment us, like Jody was talking about earlier, machines that make us better as humans, not machines that do exactly what we do. So it's an incredibly flawed picture, but it is also helpful. Regular software, regular machines does what we've told it to do. Machine learning software learns over time to give us better and better answers. And to give a very clear illustration, and the simplest possible illustration of how the two differ is that, a simple question, is this a cat? Recognizing that a cat is a cat is surprisingly difficult. Because okay, so what is a cat? If I wanted to tell a regular computer what a cat is, right? It has pointy ears, it's fluffy, it has a cute little nose, it has 4 legs. Well, so does guinea pigs, right? No, but cats are slimmer unless they're pregnant, right? And you go and you try to explain to a machine exactly what a cat is, and you can't really do that, which is why recognizing that a cat is a cat has been very, very difficult for machines, while if you show a toddler, like a little child, maybe 5 cats, maybe 10 cats, and that toddler will know what a cat is, and say in Norwegian will say meow, as opposed to, a woof, a dog. And so machines that can learn to recognize things like cats are cats is where machine learning is getting exceptionally good. And in fact, a couple of years ago, we were at the point where machines were better than humans at things like recognizing that a cat is a cat. Humans had about 5% error margins. Machines had 3.6% error margin in recognizing that a cat is a cat. It's a very narrow task, but machines are better than humans in that exact thing. All right, and I said that, AI is not that different from regular software in that it requires hardware, right? Whether it's cloud-based or local, it requires hardware, it requires software, code, and of course data, which is one of the most important things. Now, when we talk about moving towards AGI, or these intelligences that are as smart as human beings, there's a couple of things that we really don't know what to do yet. And one of them is this. Okay, so I build a hardware infrastructure, I write the code, and I train it on the data, right? Let's say, as I do in my company, we've trained it to read scientific articles. Okay, so I do that. Now, what happens if I take that machine with that code and I feed it an entirely different data set? I feed it, say, a cookbook, and I said, hey, can you make me like a creme brulee? That machine isn't going to be able to do that because it's trained for one thing and one thing only. Another thing is this idea of big data, right? Now, we've been talking about big data for about 15 years or so, but how about really, really tiny data? Because when it comes to recognizing that a cat is a cat, the internet is filled with cat. We've got all the data we need on that, but we don't have that for every single part of our business. So having machines that can deduct, and can do inference and make decisions on small amounts of data is one of those areas where we don't know yet how to do that. And if you ask really, really smart people in a variety of research fields what it takes to get there, ask a neuroscientist, and she'll say, you know what, we need to fundamentally understand the brain in order to build these machines. Ask a physicist, and they will say, no, we need to understand quantum mechanics, and we need to properly understand the physical world to get there. Ask a mathematician, they will go, no, we need to solve some basic theorems before we get there. Who's right? I don't know, but fact is that we don't know enough about the world to solve these things yet. But in the world of narrow AI, doing one thing and one thing only, post-2012, we've seen some amazing breakthroughs. And I want to just give you a quick couple of examples, which is very much in line with what you've already heard from some of the speakers. I want to show you the last physical album I ever printed. So it was summer 2006, right? And so what happened from 2006 to 2016? So in the span of those 10 years, there's a few things that happened, right? First of all, film got dematerialized because I could afford my first digital camera as a student. Second thing that happened was that the digital camera got dematerialized because I could afford my first iPhone. And then in 2016, the iPhone then had enough computational power and enough data, i.e. all of the pictures I was taking, that it could run locally its own deep learning algorithm. And in 2016, Apple's deep learning algorithm on image recognition was launched on everyone's iPhones. Meaning you can find any picture you've ever taken of a Christmas tree, any picture you've ever taken of a skyscraper, or, incidentally, of course, of a cat. And so this is kind of the speed. In 10 years, that has been enabled. So imagine what's going to happen for the next 10. And it's not just image recognition, of course. We're talking any kind of data, anything that can be turned into a number, which also includes speech. And I'm going to show you, and I'm going to make a little bit fun of Apple. Bear with me. And we're going to see a quick video of Siri in 2014.
Switch off iPhone.
Change what?
Turn off the phone.
Which setting?
The power setting.
I don't know what you mean by the power setting. Turn off what?
Phone.
Call who?
No one.
Okay.
Keeping up the context of a human conversation and human language is incredibly difficult for a machine. Now, this was 2014. Let's fast forward to 2018, and some of you may have seen this video already, and this is not to compare Apple and Google. The different companies are more or less, working at the same pace. But we're going to see from Google 2018.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we reserve for after 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh, no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Yep. Bye-bye.
And it's hard for humans as well, right, to keep track of human conversations. But obviously, the amount of things that have happened in speech generation technology and for machines to understand human dialogue, again, 4 years, and this is the result, right? So imagine what's going to happen the next 4. And again, keep in mind that Google probably has 10,000 recordings like this, and this is the one they chose to show us, right? There's probably 9,000 plus that were pretty terrible. So let's keep that in mind. But the amount of progress is incredible. But I want to get kind of to the current moment, and I want to talk about some really, really exciting breakthroughs that has happened just in the last year. But a fair word of warning, it's going to be like the real kind of breakthroughs, not what you see in clickbait headlines. You see, the thing is, if you Google, just do a regular Google search for an AI system that cures cancer, you're going to get 80 million hits, right? There's a lot of people working on curing cancer with AI. But then the question is, well, what cancer, at what stage, on what kind of people, with what kind of data, et cetera, et cetera, et cetera, right? We're working on really small, specific problems. It's not about finding one algorithm that can cure cancer. And to really just pick on one of these headlines, I wanted to show you this one. And I read it, and I go ooh, that's creepy. No wonder people are afraid of AI. And then I actually read the article, not just the title. And the title, for those of you who can't see it, says, AI can predict when someone will die with unsettling accuracy. It's very scary, right? You see this big robot that comes over and scans you and tells you August 22nd, 2025. And then I actually read the article. So I figured I would retranslate the header or the headline of this article just to show you what it's actually about. Because it is cool research, right? This is my take on it. AI can fairly accurately predict the likelihood of someone dying before reaching their region's average lifespan based on in-depth health data, showing substantial improvement over non-AI algorithm. The non-AI algorithm had it right 44% of the time. The AI deep learning algorithm had it right 76% of the time, right? It's a little bit different than predicting when you're going to die. And that's something to look out for as you see news reports on really cool AI systems, that it's usually not what it seems at first glance. Now, for a company, let's say an insurance company who's running these kinds of algorithms, going from 44% to 76% accuracy, that can give a good boost in profit margin. But it's not an AI that's going to tell you when you die, right? But here's a few things that have actually happened that are actually really cool breakthroughs that get those of us who are working on the ground with this really, really excited. So the first one is in natural language processing, right? And we've seen the improvement in Siri and Google, et cetera, over the past few years, but there are three things that have happened the last year that are very exciting. The first is transfer learning. So Google's, the call bot that orders the restaurant, right, is trained on how to order a restaurant table, right? Now, if you wanted that, bot instead to order you a train ticket, that would require a lot of retraining, right? And retraining in the span of $10,000 to $100,000. So fairly like Google could afford it, I couldn't, right? So fairly expensive retraining. But with the new with the new advancements in transfer learning, we can go from $10,000 down to about $40 in cost, right? Massive cost savings. In addition to that, Google has a couple of new algorithms called Elmo and BERT, which increases contextual understanding radically. So when I call to book a table, that is one kind of table. Tabling a discussion is something entirely different, and buying a table at a furniture store is, again, something different, right? Different context. And these algorithms have shown some substantial breakthroughs in making AI systems understand, like, which table are we really talking about. Now, OpenAI combined transfer learning and the contextual understanding to build this bot that could read any piece of scientific work and recreate and write new texts. Now, there was actually a clickbait headline that was true. OpenAI announced, firstly, that this was so good that the chance of this being misused for fake news, spreading fake news at a way higher rate than we could normally do, they saw that as such a risk, so they renounced their vow of opening up and publishing everything open source and kept that algorithm to themselves. Now, about a month later, OpenAI, which was started with $1 billion or so to really help advance humanity, as a non-for-profit, announced that they've gone for-profit about a month after that algorithm. I'm not going to put too many conspiracy theories in that, but there is a change happening there. But in any case, the point being that what we're seeing in natural language processing these days, we're going to see a massive improvement in our chatbots, in our AI-generated texts. So that's one thing. Another completely different area is video processing, where we've also seen some amazing breakthroughs. Again, it's about the training data. So retraining, for example, or training an image recognition algorithm to recognize that here's a cat and the cat is playing with a set of yarn. Training that algorithm previously might have taken you 2 full days of server capacity, which costs a lot of money. With NVIDIA's new image training GPUs, you can reduce that time from 2 full days down to 18 minutes, which means we're going to speed up a lot what we're going to be able to do. They've also, in combination with that, launched a new approach called vid-to-vid, which is about scanning videos to be able to detect, like, okay, there's a cat in the video, the cat is running over here, it's doing this thing, etc. Things that are really expensive and really tricky to do by sequencing the video. Now, what that means in practice is that where self-driving cars, autonomous vehicles today, see things moving around them as like little boxes, because it's mainly based on radar data and very kind of low-resolution monochrome videos, today you have to do that. Going forward, what we might be able to do when the prices go down just a little bit more on the NVIDIA servers is that we can have live video being translated on the go in these vehicles, which means you're not just going to see a box moving. You're going to see that it actually has wheels, and there's pedals, and there's a human on it, which means that will radically improve, if it gets cheap enough, when it gets cheap enough, it will radically improve the precision of autonomous vehicles. Right? And again, the breakthroughs are really, really small, but the implications long-term are going to be quite amazing. Another amazing area is AI and quantum convergence. Right? Quantum computing is still at its infancy, but it is very promising and very exciting. There's three things that's happening kind of in parallel that makes us very excited about where kind of quantum computing and AI can meet. The first one is that, so when a quantum computer is running, its particles can very easily get entangled with the environment, which means that the qubit, or the little computational unit, it's not easy to read clearly whether it's a 1 or a 0, as in you get noise, right? You can't read it. And what these researchers at the Max Planck Institute for Science have been able to do is build a neural network that understands what is noise and what is actually a signal, which means we can actually way more accurately use the result from that quantum computer. At the same time, some researchers at University of Pavia in Italy, they built the world's first perceptron, which is the unit that you have to one of the units you have to use in a neural network. They built the world's first perceptron on a quantum computer. So until now, we've just had this idea that we should be able to run machine learning algorithms on a quantum computer. Now that's actually done, right? So we use AI algorithms to make the quantum computers better, and we can actually run AI algorithms on the quantum computer. So the two fields are starting to converge. And of course, IBM is using a simulated environment with AI in order to actually allow us to try programming on these qubits until we actually have a functioning quantum computer. So we have this amazing synergy between the two different fields, and you can find these synergies in every field that you're looking at between AI and the emergence of whatever other technology you're looking at. And then there's an upcoming potential breakthrough, which ties very well into what Jody was talking about earlier, right? She was showing you the robots, where you show the robot like what steps to do, right? And you have to like show the actual steps. That's today. The robot sees the steps and does that, and it's great visual imaging. But there is a field called, or an area called visual grounding that looks like it might be the big breakthrough for 2019. And what that means, if I take an apple and I peel the apple and I tell the robot, I'm peeling an apple. Later, I take an orange, and I show the robot, here's an orange. 3 days later, I'm like, hey, robot, can you peel an orange? The robot will know what an orange is, it will know what an apple is, it will know what peeling is, and it will then be able to visually ground what it means to peel something and go peel an orange. And that will also radically change the way those robots work. And this is not quite figured out yet, but we've seen some really, really promising efforts in that field. All right, so that's all cool, but like, what do we do now? Like, what do we, in our companies, where do we start? And for me, it's pretty simple. The way I started my company and the way I think it's a good idea to go about this in your own companies, it's innovation 101, right? It's not magic. It's like, what part of your organization has the most tedious manual process? What problem are those people solving, and who are they solving it for? What data, here comes the machine learning part, right? What data do you need to solve the problem? And what answers do you want from that data? It's not enough to have a small, shit ton of data and then just run it through something. You need to know what answers you want. And what can you do with existing open source machine learning AI frameworks, and where do you need to actually be part of this groundbreaking new discoveries? And keep in mind all the time, and you will have seen this curve a few times before today, so I think you kind of know how this goes. This is what we see, right? This is the development we see. And all the time as you develop your AI strategy, keep in mind that that's not, this is how it's going to look like. So you can plan with this big, massive moonshot, this big idea that you want to take on. And I want to mention briefly as well, and unfortunately, we don't have all the time in the world to go through this because it's a really important topic, but there are a lot of tricky questions when it comes to AI and machine learning, starting with the fact that our human brains, as I alluded to in the beginning, our human brains are incredibly flawed, right? And the fact is that an AI system, a machine learning system, learning from humans and human behavior is no better than the humans who designed it. We are going to build our machine learning algorithms just as sexist, just as racist, just as prejudiced as we humans are. And that is something we have to bear in mind as we design these systems. And quick public service announcement, do not put weapons on autonomous machines. Period. Now, I'm not naive. we're already doing it, but like, let's not. Let's just agree to not and let's get that sorted. So where are we at right now? We've made it to the starting line of like 6 consecutive years of AI. And I want to kind of just quickly take you through a few of the things that I'm seeing that I'm really excited for that we might see sometimes in the future. You're going to hear more about the future of mobility later, but autonomous systems, whether it's cars or buses or trains or planes, will entirely change the way that we travel. Chatbots today are the worst they're ever going to be, I promise, and it will only get better from here. And I like the idea of chatbots that are personal, that give consolidated advice. So a chatbot that knows everything from your bank account to the history of your car to what plans you have for your vacation, that can give you consolidated financial advice, for example. And speaking of advice, why not have one tutor per child? Right? An AI system that follows your child, knows what they've learned already, what they didn't understand, how they learn best, where they need extra help, where they can really excel, that can relay all of that information over to the human teacher so your child really can get the best possible follow-up for them. And really, why stop at children, right? Lifestyle diseases is one of those things that are easily preventable if we only had a system that knew us a little better than we know ourselves and know exactly how to nudge us to, go make a healthy meal or get off of the couch and go move your body or whatever it is, right? And speaking of diseases, outbreak prediction. Anyone else that was scared of the Ebola threat when that went on, right? Systems that can predict disease outbreaks and help us monitor and then scale them back. Autonomy in healthcare, right? This is a microscope that doesn't actually have the looking piece. It has a small computer with a machine learning algorithm that can detect malaria samples in the blood without actually needing to have a doctor around. AI research, right, or an AI researcher that can help make sense of the millions of documents that are out there and all of the knowledge we have. And again, this is personally what I'm working on. And the future there can be quite amazing in terms of actually leveraging all the amazing human knowledge we have. And finally, this is not going to be, big industrial and cars and machines. This is in our homes as well, right? Everything we do, from controlling our lights to the temperature around us, being as green as possible, low emissions, etc. Every single part of what we do can be connected into this system. So with that, I want to wrap up simply by saying that the 5 consecutive years of AI that we've seen is merely the starting line, and if we bring a little bit of empathy and a little bit of brains into it and check our own prejudices as we go along, we can build a pretty neat future of artificial intelligence. Thank you.
Petra Škachová, one of our visitors, our spectators, our viewers, used the app SingularityU Czech Summit 2019 to ask the question.
Cool.
Talking about exponential, will the robots and androids with AI improve to the point to have their own social empathy towards other robots or people?
Depends who builds them. Depends on the empathy of the humans that builds them. Okay. And that is what sometimes make me very excited about the future, and sometimes, make me very scared about the future, depending on who I've spoken to that day.
Are you more scared or more excited?
I'm naive and simple. I'm excited, of course.
Says Anita, Schjøll, Brede. Thank you very much indeed.
Thank you.